Hi, this is Mr. Eaton with Year 7 Video Lesson 2.3, Angles at a Point. And always remember to make some notes in your note section of your exercise book and to put the video on pause whenever you need to write some notes or if you are doing some of the practice questions. Right, let's get going. So the first thing we need to understand is that not all angles in a diagram or construction actually need to be measured with a protractor. So we can actually work out some of these angles using maths. Now, in order to do that, we need to realize again that there are some special relationships that exist between pairs of angles at a point, which will help us to calculate this, even if our drawings are not even drawn to scale. So the first set of angles we're going to look at are adjacent angles, and these are angles that are side by side and share a vertex and also an arm. So I've now labeled this diagram, and obviously vertex is O, arm over here, and that at point A, arm over here, that's point B, arm over here, and that's point C. Now by definition, adjacent angles are side by side and share a vertex and an arm. Well, here is an angle AOB and angle BOC. They share a vertex and they also share this arm over here. So what we now have is angle AOB and angle BOC are adjacent angles. We're now going to look at complementary pairs of angles, and they must sum to 90 degrees. In my diagram, obviously that little symbol over there, that little box that is put in the corner over there, that represents that this angle over here is 90 degrees. So now we can say that angle A over here and angle B over here must equal 90 degrees, which is that over there. And therefore this angle and this angle must be complementary and add up to 90 degrees. We could also say that A added to B must equal 90 degrees. The next pair of angles are supplementary pairs of angles, and they must add up to 180 degrees. This angle over here is 180 degrees. How do we know that? Well, it's a straight line. So therefore, angle A, which is this over here, added to this angle over here, which is angle B, must all together add up to 180 degrees, and therefore a straight line, and are therefore complementary pairs of angles. We could also write it like this: angle A, which is that one, added to angle B must equal 180 degrees. The next one are angles in a revolution sum to 360 degrees. What is a revolution? Well, a revolution is going right around a protractor or a circle once, equaling 360 degrees. So we have angle A and angle B must equal 360 degrees, and therefore a revolution. And we write that as follows: A add B equals 360 degrees. The next special relationship we find is vertically opposite angles are formed when two lines intersect. The opposite angles are equal. So in this diagram we can see that this angle over here, which is angle A, is vertically opposite to this angle over here. Therefore A is the same as A. And likewise this angle over here is vertically opposite to this angle over here. Therefore B equals B. Finally, we have perpendicular lines meet at right angles, and we all know that that little symbol in there, which is a little box in this angle over here, denotes that that is 90 degrees. Therefore, if that is 90 degrees, that would have to be 90 degrees because that is a straight line, which equals 180 degrees. Equally, that one has to be equal to 90 degrees, and that one has to equal 90 degrees because that is a straight line. Well, let's do some practice now. So without using a protractor, find the size of each of the angles marked with the letter A, that one over there. Pay attention to this little thing over here. I'm not going to tell you what that is. You can work that out for yourself. Find what the value of A is, please. Put the video on pause. Well, I hope you remembered that that little symbol in there equals 90 degrees. So what type of angles are these two over here? Well, they happen to be complementary pairs of angles. So we should recognize that angle A added to angle 35 over here must equal 90 degrees. So we can write that as follows. A plus 35 must equal 90. Therefore A equals 90, subtract 35, therefore A must equal 55 degrees. And there you have your answer. Right, well, have a go at this one. I want you to find angle A, please. Put the video on pause. Well, how did we go? Well, first thing we need to have recognized was that angle 55 and angle A are actually supplementary pairs of angles. And as such, supplementary pairs of angles must equal 180 degrees. So we can write that as A plus 55 equals 180 degrees. So now we need to solve for A. A equals 180 degrees, subtract 55. And our answer therefore is 125 degrees. Problem solved. Okay, final problem. Solve for angle A. Put the video on pause and have a go. This one's just a little bit more complicated, but we can find, or we can realize, that this is actually a revolution and therefore equals 360 degrees. So angle A added to that angle over there, which is 90 degrees, added to 120 degrees, must equal 360. So I can write that as A add 90 add 120 equals 360 degrees. So therefore A equals 360 degrees, subtract 90, subtract 120. Therefore angle A is equal to 150 degrees. Problem solved.